Have you ever tried something strange? Right now, point down. Go ahead, point toward the ground beneath your feet. Now imagine someone standing on the exact opposite side of Earth. They're pointing in the opposite direction. And they're also calling it down. So which one of you is right? The truth is, neither of you are. Because in space, down doesn't actually exist. The idea of up and down only works on Earth because gravity pulls us toward the planet's center. But once you leave Earth and enter space, those directions disappear. And that raises a fascinating question. If our solar system is usually shown as a flat disk of planets orbiting the sun, what actually exists above it? And what exists below it? For a long time, scientists thought the answer was simple: almost nothing. Just empty space. But as our spacecraft traveled farther from the sun and our telescopes began revealing more about our cosmic neighborhood, we realized something surprising. Above and below our solar system isn't empty at all. Instead, it's filled with enormous structures, invisible boundaries, and cosmic environments that connect our tiny planetary system to the vast galaxy beyond. And the deeper we look, the stranger it gets. Let's start with something that seems simple. Why is the solar system flat in the first place? If you look at most diagrams of the solar system, the planets appear arranged like grooves on a vinyl record, all circling the sun on roughly the same plane. This plane is called the ecliptic, but the reason it exists goes back 4.6 billion years to the moment our solar system was born. Back then, there was no sun, no planets, no Earth. There was only a massive cloud of gas and dust drifting through space. Under the pull of gravity, that cloud began to collapse inward. And as it collapsed, something important happened. It started to spin. Just like a figure skater pulling in their arms to spin faster, the collapsing cloud began rotating more rapidly as it shrank. That rotation caused the cloud to flatten. Instead of remaining a sphere, it turned into a spinning disk of gas and dust surrounding the young sun. Inside that disk, particles collided, stuck together, and slowly grew larger. Pebbles became rocks. Rocks became planetesimals. And eventually, those planetesimals became the planets we know today. Because they formed inside that rotating disk, the planets still orbit within the same flat plane billions of years later. That's why Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all travel around the sun in roughly the same direction. Not perfectly aligned, but close enough that the solar system appears flat. But here's where things start getting interesting. Because that flat plane is only part of the story. Most illustrations show the solar system as if it were perfectly aligned with the Milky Way galaxy. But it's not. In reality, the plane of the solar system is tilted about 60 degrees relative to the plane of our galaxy. Imagine a spinning coin resting on a tilted table. That's essentially how our solar system sits inside the Milky Way. And as the sun orbits the center of the galaxy, traveling at roughly 15,000 miles per hour, our solar system moves through space at an angle. So if you travel straight up from the solar system, you're not leaving the galaxy. You're cutting through it, through stars, through gas clouds, through enormous cosmic structures that stretch across thousands of light years. But before we get that far, we encounter something closer. Something that surrounds our solar system in every direction. A protective bubble created by the sun itself. The sun constantly releases a stream of charged particles known as the solar wind. These particles flow outward in all directions, racing through the solar system at incredible speeds. Eventually, they collide with particles drifting through interstellar space, the thin gas and dust that exists between stars. Where those two environments meet, a boundary forms. The solar wind pushes outward. Interstellar particles push inward. The result is a vast bubble surrounding our solar system. This bubble is called the heliosphere, and it extends far beyond the orbit of the outermost planets. For decades, scientists believed the heliosphere looked something like a comet. Rounded at the front, with a long tail stretching behind as the solar system moved through space. But when spacecraft finally reached its edge, the story changed. In 2012, Voyager 1 crossed a mysterious boundary roughly 11 billion miles from the Sun. Suddenly, the environment around the spacecraft changed dramatically. Solar wind particles dropped. Cosmic radiation increased. Magnetic fields shifted. Voyager 1 had reached the heliopause, the outer edge of the Sun's influence. It had entered interstellar space. A few years later, Voyager 2 crossed the same boundary from a different direction. And the data revealed something surprising. The heliosphere wasn't shaped exactly the way scientists expected. Instead of a smooth comet-like tail, it appeared distorted, uneven, possibly compressed by magnetic forces from the surrounding galaxy. In other words, the bubble protecting our solar system isn't perfectly symmetrical. It's shaped by the environment of the Milky Way itself. But even beyond the heliosphere, the solar system still hasn't truly ended. Because surrounding everything, the Sun, the planets, and even the heliosphere, lies one of the most mysterious regions in astronomy. A vast sphere of frozen objects called the Oort cloud. Unlike the flat disk of the planets, the Oort cloud extends in every direction. Above the solar system, below it, and far beyond the outer planets. It may begin around 2,000 astronomical units from the Sun and stretch as far as 100,000 astronomical units. To understand how enormous that is, consider this. Neptune orbits about 30 astronomical units from the Sun. The Oort cloud may extend more than 3,000 times farther. At those distances, the Sun appears as just another bright star. And yet, trillions of icy objects may be orbiting there. Fragments left over from the birth of the solar system. Early in our solar system's history, giant planets like Jupiter and Saturn scattered countless icy bodies outward. Some escaped completely. Others settled into enormous orbits, forming the spherical cloud that surrounds us today. We've never directly seen the Oort cloud. It's simply too distant and too faint. But we know it exists, because sometimes objects from it fall toward the Sun. These are the long-period comets. Unlike short-period comets that orbit within the planetary plane, long-period comets arrive from every direction, above, below, and sideways relative to the solar system. Their strange orbits are the fingerprints of the Oort cloud. But the story doesn't end there. Because even outside the Oort cloud, we're still not alone in empty space. Our solar system is currently drifting through a region called the local interstellar cloud. This cloud is a patch of slightly denser gas and dust within the interstellar medium. It surrounds us in 3 dimensions. And as the Sun moves through the galaxy, it slowly passes through different regions like this. Think of it like a ship traveling through changing currents in the ocean. Sometimes the water is calm. Sometimes it's turbulent. The same is true for the solar system as it moves through interstellar space. Zoom out even further, and the environment becomes even more dramatic. The solar system sits inside an enormous cavity in space known as the local bubble. This bubble stretches roughly 4,000 light-years across. Compared to the surrounding galaxy, it contains unusually little gas and dust. Astronomers believe the local bubble formed when multiple supernova explosions occurred in our region of the galaxy millions of years ago. Each exploding star blasted surrounding material outward, carving out a vast cavity. Over time, these expanding shock waves merged together, leaving behind the bubble we now occupy. In other words, our solar system may be floating inside a region sculpted by ancient stellar explosions. And beyond that lies something even larger, the galactic halo. While the Milky Way is often shown as a flat spiral disk, that disk is surrounded by a roughly spherical halo containing ancient stars, globular clusters, and possibly enormous amounts of dark matter. This halo extends far above and below the galaxy's main plane. Some of the oldest stars in the universe reside there, which means that if you travel far enough above the solar system, you eventually leave the crowded disk of the Milky Way and enter this vast halo of ancient cosmic history. At every scale, the same pattern appears. The solar system isn't a simple flat disk floating in empty space. It's embedded within layers of larger and larger structures: the heliosphere, the Oort cloud, the interstellar medium, the local bubble, the Milky Way galaxy, and beyond that, galaxy clusters and cosmic filaments stretching across the universe. Each layer reshapes the meaning of above and below, because in reality, those directions only exist relative to whatever system you choose as a reference. From Earth, down, points toward our planet's center. From the solar system, up might mean away from the ecliptic plane. From the galaxy, up could mean away from the galactic disk. The deeper we explore, the more we realize that orientation itself is arbitrary. And yet, within this enormous cosmic structure, life emerged on a small rocky world orbiting an ordinary star. A civilization capable of asking questions about the universe, capable of sending spacecraft billions of miles into space, and capable of wondering what lies above and below. Voyager 1 is still traveling outward today. One day, tens of thousands of years from now, it may finally pass through the Oort cloud and leave the solar system completely. But by then, humanity may already have discovered far more about the cosmic structures surrounding us, because every time we explore deeper into space, we discover something unexpected. New boundaries, new environments, new mysteries. So what actually exists above and below our solar system? Not empty space, but layers of cosmic structure stretching outward into the vast architecture of the galaxy. And we're only just beginning to understand them. If you enjoy exploring the hidden structure of the universe and the mysteries of space, consider subscribing to the channel. Because the deeper we look into the cosmos, the more incredible it becomes.